Are the millions of American manufacturing jobs lost over the last 40 years ever coming back? The short answer is no, but the factories themselves? They are already here. This chart shows U.S. industrial output and manufacturing employment from 1980 to today. While the line representing the physical output of American factories surges to historical highs, the line tracking the human labor force drops to near-record lows. In June 1979, the sector reached its absolute employment peak, with nearly 20 million Americans working on an assembly line or a factory floor. The 1979 peak serves as a historical baseline for an industry that has since moved toward a total structural transformation. The factory is no longer a collection of manual workstations. It is becoming an autonomous, capital-intensive machine. That transformation hit a violent acceleration point in 2001, with what economists call the China shock. China's entry into the World Trade Organization triggered a sudden surge of imports into the United States. Local labor markets heavily exposed to Chinese competition collapsed, displacing almost 3 million manufacturing workers. For years, the accepted explanation for this job loss was domestic automation. The logic seemed sound. If output was staying steady while jobs disappeared, machines must have been doing the work. But economist Susan Hausman investigated the underlying metrics and found a structural flaw in that productivity narrative. This area chart breaks down manufacturing productivity by sector. Notice this isolated vertical spike. It doesn't represent widespread automation across all industries. It is contained entirely within one category: computer and electronic products. Statistical agencies were logging the exponentially increasing processing power of semiconductors as a surge in manufacturing output. When you remove the computer sector from the data, the picture changes. Real manufacturing growth flattens out into a near horizontal line, lagging far behind the rest of the private sector. Traditional manufacturing didn't elegantly evolve through the use of robotics during the 2000s. It was gutted by offshoring. Understanding that reality changes the baseline for how the United States has to rebuild its industrial base today. In 2020, the pandemic forced the intricate global just-in-time supply chain to stop moving entirely. Executives responded by adopting strategies like reshoring, moving operations back to the U.S., and friendshoring, sourcing materials from politically aligned allies. The priority shifted from finding the cheapest available labor to mitigating geopolitical risks. For decades, corporate strategy was dictated by the lowest landed cost, the cheapest price to manufacture a good overseas and put it on a boat. Now, companies rely on the total cost of ownership model. This equation factors in the previously hidden financial risks of operating overseas, fluctuating tariffs, intellectual property theft, and holding safety stock inventory to prevent another shutdown. The current push to bring factories back to American soil has nothing to do with nostalgia. It is a defensive maneuver prioritizing physical supply chain resilience over short-term profit margins. To accelerate this return, the federal government launched hundreds of billions in direct industrial subsidies. The 2022 CHIPS and Science Act specifically targeted the domestic semiconductor industry to reverse a 30-year decline in manufacturing capacity. This policy triggered a $400 billion influx of private capital. The money is flowing into new regional innovation clusters designed to secure leadership in critical technologies. Inside these facilities, the technology has moved past the simple, repetitive automation of the early 2000s. These are AI-native operations, where generative models handle non-routine logistical decisions, and predictive algorithms schedule their own repairs before a machine even breaks. The modern factory functions as a capital-intensive tech ecosystem. It relies on high-cost, autonomous hardware rather than rows of human workstations, allowing output to scale while the headcount stays flat. Because these systems operate largely autonomously, industrial capital has successfully returned to American soil without bringing the millions of jobs with it. Yet, despite the influx of hundreds of billions of dollars and cutting-edge robotics, the entire reshoring movement is hitting a wall. This chart visualizes the human capital deficit. It shows a 2 million person gap between open high-tech manufacturing roles and the shrinking pool of qualified talent. By 2030, current projections show that 2.1 million jobs will sit completely empty. The economic stakes of this shortfall are severe. If these advanced positions remain vacant, the resulting delays and lost production could drain $1 trillion from the U.S. economy by 2030. Advanced machinery still requires highly specialized technicians to program and orchestrate the systems. Without those workers, the defensive geopolitical strategy of rebuilding the American supply chain falls apart. To prevent this collapse, manufacturers are abandoning traditional hiring models and looking for talent in entirely new places. One pivot is second chance hiring. Companies are actively recruiting justice-impacted individuals with past criminal records. Data shows these hires consistently demonstrate fierce loyalty to their employers, resulting in turnover rates well below the industry average. There is also a renewed push toward advanced apprenticeships. These programs bypass standard 4-year degrees, directly training a younger generation to operate within highly complex AI-assisted environments. The total collapse of American manufacturing is a myth, but the idea that we are going to restore the assembly lines of the 20th century is equally false. Instead, the United States is engineering a highly autonomous, remarkably resilient industrial hub